In this final segment, we're going to look at horizontal dilations of quadratic functions. So horizontal, right and left, right? And dilation means stretch or compress. So just like the fact that when you add something inside the function in the horizontal way, it moves it left, and when you subtract it, it moves it right, which is kind of counterintuitive, at least for me. The horizontal dilations also work in a kind of counterintuitive way. If you multiply by a scale factor here, multiply x by a scale factor, you might think it would get bigger like it does in the vertical direction. It does not. It actually compresses the graph by a factor of k. And if you multiply by something less than 1, something between 0 and 1, it's going to stretch the graph by a factor of k. And let's check that out. We're going to look specifically at this function. We're going to explore it with the calculator. So x squared minus 12x plus 20. All right, so I'll try to speed this up a little bit so you don't get bored. So here's where, to enter our g of x and our h of x, we're going to want to use that y1 feature again. It's not going to be something to y1, it's y1 of 3 of x. So we're going to do y1 parentheses 3x. And we'll do the same for the h of x function. Make sure you notice the particular placement of the parentheses. It's y1 of 3 of x, y1 of 1/3 x. And now we're just going to make sure we got our colors. Our colors are all good here. So let's go ahead and just hit zoom 6 and examine that graph. So you can see this isn't the ideal window range to examine the properties of these three graphs. So let's go to window. I think we want to expand it in the vertical directions, both directions, and also in the horizontal direction in the positive x. So let's go for our window range. Let's go between 0 for x to, let's go up to 40 for x for the maximum, from 0 to 40, and then the y's, let's go with negative 20 to positive 10, should be fine. And so we'll just hit graph here. All right, so doing it this way, using the y1 feature, maybe saves us a little typing time. It looks like it doesn't save us very much time when we actually have it make the graph. It looks like it really cranks to do that. So nonetheless, we have our three graphs, and now we can examine the characteristics. So I made a little screenshot of the three graphs here, and we can examine them, and we can just sort of summarize. So we had our original f of x graph. When we multiplied by a scale factor of 3 inside the function, that compressed the graph. Okay, all the y values stayed the same. You can see that the turning points are all have the same y value. We should probably make that note. Let me add that here. Turning points have same y value. And the g of x is 3 times as compressed. Okay, its turning point would be 2, whereas the turning point of f would be 6. You might imagine the turning point of h would be 18. Maybe we can label each one of those just for our notes. So here's our summary. G of x is compressed by a scale factor of 3 because the 3 is the coefficient of x. It's inside the parentheses, so it's horizontal. H of x is stretched by a scale factor of 3 because it's multiplied by a 1/3. Okay, it's a scale factor between 0 and 1. It's the reciprocal that it's stretched by. And that all our turning points, the y values, have the same value. They are unaffected by that horizontal stretch. Thanks for watching.